Hey, good morning. Hey, good morning, everyone. It's working on. Oh. It's okay? Testing? Yeah, it's okay now. So the first assignment has been released. So I sent you an email yesterday. So I was wondering if you guys have got time to look at this assignment specification. Yes? Okay. This first assignment basically is about the C++ programming. Of course, you need to use some data structures coming with the C++ compiler. So there are basically two sets of requirements. One is functional requirements. So I think the functional requirements are pretty straightforward. For example, you need to use the system. First of all, you need to design a main menu. And on the main menu, you have a number of functionalities. So for example, you can use the system to book a swimming lesson with a club through a staff member, not booked by yourself, but everything is done through a staff member in the cloud. The reason why I make this assumption is just to make the assignment a little bit easier. Otherwise, you would have two kinds of users. You have a staff user, and you have general users, right? So, and the second function basically is a cancel booking, swimming lesson booking. And the third function is to display the current schedule for a swimming instructor. So basically, for this assignment, we assume there are only 5 instructors in that class. All right, so they can show, for example, actually there is an example given in the specification. For example, if we want to show Jeff's, which is here, the name is here, right? Jeff's schedule or timetable, whatever you call it, then it should look like similar to that. All right, and also we assume the swimming lessons are only available during working days, which basically is from Monday to Friday, and the time is from 9 to 5. So we just make some assumptions to make this assignment a little bit easier. And another function that you need to implement in this assignment is you need when a user or a club member want to book a swimming lessons with an instructor. So sometimes they don't know if the instructor is available at a particular time. So that's why we have this function. So for this function, you need to display the availability of all the instructors or the available time. So basically, so for this one, you can look at this one here. So for example, on Monday, from 9 to 10, so nobody is available. And from still on Monday, from 2 to 3, all the 5 instructors are available. So you just give them probably initial, right? So this is just the initial for all the 5 swimming instructors. Okay, so this is another functionality. And the last one is you clear up all the schedules. All right. So for this one, if you look at closely, the requirement for this assignment, so you don't need to use file input and output. So you don't need to save, for example, schedule for instructors in a file, and then when you bring up the system, you load the file into the system. So you don't need to do that. There's no file input output needed for this assignment. And also, this system is designed for booking, is for 1 week only. So for example, only booking for the coming week, right? Only for 1 week. So you cannot book a swimming lesson, for example, for the week after next week. You can't do that. Only 1 week. The reason is we keep it simple, right? Because this assignment is an individual one, and the weighting is only 20%. So I don't want to give too much work to your guys for this first assignment. That's the only reason. So this is just a simplified, or maybe it's a prototype system for swimming license booking. All right. So this is a very simplified system. It's not cannot be actually directly used in the real world. But the core part, yeah, is a demo system, right? Submissions. Oh, so for this one, you have to use C++ because the only program language used in this unit is C++. So it has to be C++. And also, you have to use this one, use this IDE to develop our project, all right? So if you look at the application or the project type for code blocks, there are quite a few, probably 20 or 30, right? The one you should use is console application. So I don't want your guys to develop, for example, GUI applications. This is just a console or command line applications, so which is pretty simple. That's the one that you use in every the weekly particles, right? And for this one, you can use. There is some specific requirement. So the first one is you need to develop an ADT abstract data type for schedule. So you need to develop a more specifically, actually, you need to define and implement a class called schedule, all right, to model the schedules or weekly schedules for the instructors, all right. So, and you have to, in your application, your main program, you have to use this schedule class that developed by yourself, all right. This is a very specific requirement. So if you look at, actually, there's a marking criteria on the last page, right? So you need to check the marking criteria. For example, as you can see from there, the first part is about ADT, because we have only ADT, user-defined ADTs, right? So which is a schedule. So there are some specific requirements. So the marker will check your class specification. We're talking more. We're for example, header files, which is schedule.h. We're talking about more today. And also your implementations, okay, that's the corresponding CPP file. And those are the functionalities. Okay, so we are checking if you have fulfilled all the functionalities, all right? And of course, I mentioned earlier there are two sets of requirements. One is about the functionality, and the other one is non-functionality. So for example, non-functional, that's about your program's quality. For example, if you use dynamic memory, which I was supposed to talk about last week, but because I ran out of time, I didn't have to talk about, but I will talk about right after this, talking about dynamic memory management in C++. So if you use dynamic memories, then we will look at, you don't have to. If you use dynamic memories, then we will look at, for example, your dynamic memory management. So for example, if there is memory leaking problem, so you use dynamic memory, you claim the memory during the runtime, but you did not return the memory back to the operating system. So if this is the case, then you probably get some penalty for this one, for dynamic memory management. And also, because this subject is about data structures and algorithm, in this assignment, you definitely use a sort of some data structures. So we will look at the data structures, the use of data structures, if you select or use a right data structure for this assignment. Okay, so we are looking at which data structure. So you need to make a decision. So which data structure you should use, you know. And also about the readability. So we look at your source code to see if it's easy to understand, right? If it's easy to read, to understand. And usability. So for example, the system that you develop is easy to use. Sometimes, you know, student, you know, developer, for example, a system with a main menu, sometimes it's pretty tricky. It's very hard. It's not that straightforward to work out how to use the system, right? So this is about usability. So if it's easy to use, you get a 4 mark. There's no penalty for that. If not that straightforward, you may get some minor penalty for that. And of course, reliability. Reliability, so for example, if I don't want to say your system will crash, you know, when I test your action, not me, actually the marker will when you test your program is crash, you know, somewhere in the middle. So this is about reliability, all right? So your system should be robust, should be pretty reliable, all right? So this is about qualitative, the marking criteria. So before submitting your assignment, so I would suggest you check against those criteria one by one, right? So because this is some criteria-based assessment, right? We will check, we'll mark your assignment, we will check against the criteria one by one. All right, so this is very important. And submission, this is deadline for submission, and the 5th of April. So you have to submit it through the Blackboard. So in the Blackboard, so if you go, I can show you. So if you go to assessment, scroll to the bottom, you can see this assignment 1 over there, all right? So this is the assignment specification in PDF file, all right? So you can bring up to look at the PDF file. And when you submit, you should, actually I have already explained in the assignment specification, but I just want to demonstrate how to do that. If you click on assignment 1, there is a submit button over there. So if you create, you know, developer project and a zip file, and then you submit. So and you can here you can put some comments if you want, and you can attach the file to your submission. And finally, you can click. If you click the submit button here, then you can, you know, you actually you can use our assignment will be submitted to the system. So for this one, as I indicate in here, you can attempt many times as you want. It doesn't matter. So for example, initially, if you develop a solution, so you can submit your solution first. And if you have more time, you want to, you know, improve your solution, that's perfectly fine, and then you submit a second or improve the solution, which we are override the private submissions. That's perfectly fine, no problem. So you can resubmit your assignment as many times as you like, but as long as before the deadline. After the deadline, the system will be closed. So there's no way, actually, nobody can actually resubmit the assignment. So once it's closed down, once the submission system is closed down. And one more important thing I want to emphasize today is, for this submission, the system will automatically check plagiarism. So they will compare your assignment with other people's assignment to see if there is any similarity. And the system, not me, the system will pick up, you know, if the system believes there are some similarities or significant similarity between two pairs of assignments, they will report, automatically generate a report and send it to you and also send to me, maybe in the faculty, in academic faculty, in the faculty. All right. So just pay a little bit more attention to that. So in the past, we didn't active that functionality, but now the school encouraged us to use that. So this has already been activated, right? So when you submit, they will automatically do that for you. 1 second, there's a hand up over here first.
Do you have to use the GNU compiler?
Sorry, GNU compiler, yes, C++ compiler, yes.
It has to be the GNU framework copy any other one.
Which one do you want to use?
Which one can
So any particular reason you want other use compiler? Then use GNU C++, all right? Unless you have a particular reason for that. Otherwise, what's the point? Use others.
Do we have to submit a statement of completeness?
Standard what, sorry?
Statement of completeness, like in other programming units?
No, not for this assignment, no. So basically for this assignment, you only submit the project, include the source code. There is no documentation, right? Because these are very simple C++ assignment. There's no statement of completeness, no. Any other questions? No? Okay. If you guys have any questions at any time, you can send me an email. You can probably give me a call or maybe send me a quick email. If the question is common, then I will create another document, probably something like a frequently asked questions and answers, and put somewhere here, maybe right after this, the document. So please keep an eye before asking questions. Please keep an eye on this, on the document, frequently asked questions and answers. So I believe most of the questions will be covered by the frequently asked questions and answers. If it's not covered, send me an email. And again, if the question is common, so I will answer a question, I also include in the frequent asked questions and answers in the document, all right? And of course, you can always ask me, send clarification with me, or even ask a tutor at any time. Any questions? Okay. Last week, we introduced quite a few, talking about quite a few C++ topics. For example, pointers, which probably was new to some of you, because I know quite a few of you have already done C or C++. So for those of you that are not new to you at all. But also I talk about reference. I talk about what's the difference between reference and the pointers. So some of you probably asking me, why would you bother? We have pointer. So why would you bother? Why would you bother to to talk about a reference? The reason is actually you will see into this lecture. There are quite a large number of standard C++ class libraries, right? In class library, there are a lot of functions, and some function, for example, take parameters of reference type. Some parameter take the parameters of pointer type. So this is why I think actually you will see there is one function for input and output which uses reference. So if you have no idea at a reference, then you would not be able to use that function properly, right? So this is why I introduced the concept. And also in last week's lecture, I talked about, actually didn't spend too much time because of time limitation, about string in C++. And I told you there are two types of strings in C++. One is we call it C-style strings, which was covered in last week's lecture. So basically, C-style strings is treat a string as an array of chars. All right. So actually, we introduce C-style strings as an example of arrays, right? So we're talking about array, and the string C-style string is an array of chars or characters. All right. This is the one I'm talking about. Today, I will continue to talk about C++ strings. But this is the second type of string, which is class. Right? So each string basically is an object of string class type. String class is a standard class common with the C++ compiler. Okay, we'll talk about more detail. Okay, in more detail. So again, why? So maybe the second step probably is more than is easier to use. Why would we bother to learn C-style string? That's because of the same reason. Because also you will see there are quite a few functions in the input and output class libraries where they use C-style string. And also sometimes they use a C-style, sometimes they use a string object, the second style. All right? So this is why I would like to spend some time talk about the traditional strings in C++. I also talk about the modern string in C++. I will talk about how to do the conversion, how you transfer from one type of string to another into this lecture, right? But before doing that, just to quickly talk about dynamic memory management, which I was supposed to talk about last week. So there are, for those of you who have only background in C# or Java, you should pay a little bit more attention to the two topics in C++. One is the pointers, right, which I already covered in last week's lecture. Another one actually is also related to the pointer, but it's a separate topic. It's called dynamic memory management, which I will briefly talk about today. So sometimes when you write a C++ program, for some variables, you can, their memory actually are given during the combination time. So when you translate your C++ program into machine code, you say, oh, in my program, I use an integer variable. So the compiler will give a piece of memory for storing that integer. Okay? This is done during the combination time when you do the translation from C++ code to machine code. But sometimes you probably don't know. So what the size of, for example, how many memory do I need? For example, the array, what's this, because we're talking about a dynamic array in a couple minutes time. You don't know the size of the variable beforehand, all right? So this has to be done during the runtime. During the runtime, for example, if I want to get an array which can store 10 integers, then you need to put a request, a runtime request, to the operating system. And the operating system then give you a block of memory for store integer, for 2 integer, array of 2 integers, right? So if this is the case, then you have to use dynamic memory. You have to get the memory during the runtime rather than during the combination time. All right? We'll talk a little bit more about that. So how to get the dynamic memory? So this sort of memory we call it dynamic memory. The memory that are located to the variables at the combination time we call static memories. All right? This is a difference between static and dynamic memories. Right? So for dynamic memory, this probably is not a new to your guys. We use new operator. This is the same with the new operator that you use in C# and Java. All right. So this is an example. So for example, if you wanted to so this is a syntax. There are two types of new statement basically. So if you want to get, for example, a single memory for one type of variable, you can use new. If you want to use a dynamic array, then you should use the second syntax, which includes capacity. That's the one with a subscribe operator. So this we call subscribe operator. Anyway, so this is an example. So for example, if you want to during the runtime, if you want to get piece of memory to store one integer, which is 4 bytes basically. Then you can do this, right? So you can declare a pointer type, for example, array pointer, which is this is a pointer type, right? You can, the second one, you can use new int. That's the first syntax, right? New int. And then you return, during the runtime, the operating system will give you a piece of memory which is enough to store one integer. And then return the address of the memory back to this pointer. So the pointer APTR store the address of the newly allocated memory. All right? And if you want to create a dynamic array during the runtime, if you want to create an array runtime, for example, the array size is 6 during the runtime, not during the compilation time. This is what you should do. You use a new operator followed by, because the element type of the array is integer, so this is an int, and this is the size, which is 6 for this instance. So this is an illustration. So basically, for array PTR, this is a declaration. Array PTR is an array variable. So when you do this piece of memory is given to you, but this is allocated to you during compilation time. So this is static memory allocation. So this piece of memory is given to that variable during the compilation time. And this piece of memory is allocated by our operating system to your program during the runtime. Okay, during the runtime. So this is the piece of memory, and this is the initial, the address of this piece of memory. So this will be stored over there. Okay, so this is how it works. So there are some difference between the new in C# and Java and the new in C++. In C# and Java, when you use new, then it has to be a class type, new followed by a class constructor, right? But in C++, when we say object, so when we say object in the context of C# and Java, we refer to the object of class. Where in C++, when we say object, more broad, more general. For example, this we can also say this is for example, we create a for example, object of new. This is a built-in type. It's not a class type. We also call object. All right. You can also use a new to create a, for example, object of int type. But this is something that you cannot do in Java and C#, right? So this is a difference. And for the dynamic memory, is the programmer's responsibility for, I'm talking about C++, of course, is the C++ programmer's responsibility to manage all the dynamic memory that they created during the runtime. Then how to, this is different, right? In C# and Java, you don't need to worry about the dynamic memory. You don't need to reclaim the dynamic memory that you use in your program. Why? Because you got a garbage collector, right? So if an object is no longer referenced by only program, then it will be automatically claimed by the system. But this is not the case in C++. In C++, there's no garbage collector, which means it's you or programmer, C++ programmer's responsibility to reclaim, to destroy, to return the dynamic allocated object, the memory, back to the operating system. Okay, how? We use another operator called delete. All right. So there are two types of delete. One is delete, is to delete a single memory. Okay, the single memory, for example, when I say single memory, for example, you use a new int. This we call a single memory. There's a piece of memory which is enough to store an integer. You can return that memory back to the operating system. The second one, that's the dynamic arrays. So when you create a dynamic memory, if you use new, then you should use the first one, delete, followed by the pointer type for pointer variable. Then by doing that, they will return the memory back to the operating system. Otherwise, the memory will not be available by anybody. This is what we call memory leaking problem, which is a very common problem in C++ programs. The second one, if you use a dynamic memory, for example, you create rather than a single memory, you create, for example, a dynamic array. So using new followed by subscribe operator. If this is the case, you need to use the second syntax. This is to delete, a number of sequential, continuous memories, right? So this is if you use the second one, all right? Single memory, use first one. A number of memories, then, for example, dynamic array, use the second syntax, all right? This is very easy to understand, right? There's one thing I should emphasize. When we do this, for example, delete, this does not delete the pointer, the memory used for the pointer, but the memory pointed by the pointer. So I can use this one as an example. So for example, you have a APTR, which is an integer pointer type. So we got a piece of memory. For this is memory. This memory we got during the runtime, during the combination time, right? Once we do this, this is done. This allocation is done during the runtime. During the runtime, at this point of time, when we execute the new statement, new operator, the operating system gives you this piece of memory, right? And then return this piece of memory. There's no name given associated with this piece of memory. So this is an anonymous memory. And then return back to here. So for example, if the address is 100, the value would be 100. So there's something like that this is pointed to this location. Okay, now if we do this, if we delete APTR, which piece of memory will be returned back to operating system? That's right, this one. This one will be returned back to operating system. Not that one. Because the lifetime of this variable is, or depending on the scope, right? So because this one we got during the combination time. So this memory will be reclaimed by the operating system only when we leave the scope, we run out of the scope. For example, if this is one in a function, so when we finish the function call, this piece of memory does not exist anymore. Right? But again, when we say delete, we delete this dynamic memory, not that piece of memory, but this dynamic allocated memory. Okay? Any questions? Yes?
Would you be able to full screen the slides, please?
Oh, sure. Oh, sorry, I forgot.
You're right.
Better? Okay. All right, so this is the delete operators, and there are some examples. So demonstrating how to use the two type of delete, right? So for example, this is for the first type, the top one. So this pointer doesn't work very well. So this is for the first one, the single memory. This is what I call single memory, and this is for dynamic array. So you dynamic create an array, integer array of, of this big, and then after, if you don't use it anymore, then you delete. So this is the syntax. All right. Yes.
I understand why you might want to make a dynamically allocated array. You might not know what size you wanted.
Right.
But why would you want dynamically allocated?
This is a good question. I'm afraid I can't give you an example right now, but sometimes you don't have to do that. But sometimes you can do that, but you don't have to do that, right? So sometimes you may want to create a dynamic variable only for single element, and not for a dynamic array. But anyway, but this is pretty. It's pretty rare to use this one, to use this syntax. But in C# you can do that. Yes, you can do that. But that's not necessarily mean you have to do. If you have a better way to use, for example, use a normal variable, so you don't need to bother use a dynamic one, just to cause some problems. Yes. So say louder. Yeah.
How pedantic do you want us to be with memory management and assignment? I mean, do you want that every variable?
As I said earlier, dynamic. So one of the 5 criteria for the quality of the program is dynamic memory management, right? So this depends. Depending on if you use any dynamic memory or not. So if you did not use any dynamic memory at all in your assignment, that's okay. Of course, we are looking at it a reasonable lot, but that could be some place where it's perfect to use a dynamic memory, but you did not use, you also get a penalty for that because you choose, for example, wrong data structure or wrong data type. If you don't have to deliberately, to make up some examples, to use dynamic memory in assignment. This is what I'm trying to say. So we look at the dynamic memory. If essential use a dynamic memory, or you actually use a dynamic memory program, then we will look at the memory management. So for example, did you delete that object? Did you delete the dynamic memory at the end of a program or not? So this is something that we'll look at when marking ourselves. Any other questions? Okay. Okay, I think probably this is the most important one. If we don't delete, and also delete related to, I think most of you, if not all, should know the structure, which are talking about in today's lecture. Okay, this is an example to use a dynamic array. So very quickly, so for example, this is a C++ program which we used number 1. Where we use the 2 functions. Those are the 2 functions prototypes. The first function called fill array. So as the name implies, basically is to create an array. You fill, give the number, you create an array element, right? You get a number and fill. Initially, the array is empty. So in the field integer, use the integer to fill the array, right? And the second one is a linear search. So for example, this is an array of integers. Giving an integer, so you need to check if the, which we call k here, give an integer, if the k is present in the integer in array or not. If it is in the integer, it simply return the index or the located index of the element in the array. Otherwise, you return -1, indicating the k or the integer that you're looking for is not in the array. It's as simple as that, right? Very simple. So initially, so we just, this proved to, okay, this program is for this, searching for a list of integers, and then we declare an integer variable called array size. And then we ask the user to input how many numbers you want to put in the list or in the array. So for example, the user from the keyboard put 10. Then we get a 10, and then put the 10 to this integer variable. Now the value of this integer becomes 10. Right? Now, because this is a 10, we dynamically create an array. So this is done during the runtime. At this point of time, we create an array of size 10, which just big enough to contain, to accommodate 10 integers. That's it. And then we ask, And then we make a call to this function. Basically, is to asking the user to input the 2 integers, right? Which you will see in a few minutes time. And then so this is the first part of the program. First part is to fill the array, all right, by calling this function, which I will show you in 1 minute. And once we have filled the array, then we do search, linear search, okay? So we're asking the user to put a number to search for, and we get a number and put in a variable k. And we search, how to search, we make there's a second function. So this is the second function. The first one is the array's name. The second one is the size of the array. Because in C++, again, I mentioned that in last week's lecture, in C++, array is not a class. Array is just a fundamental, it's a built-in fundamental data type. So there's nowhere we can get the size of the array. So that's why in Java and C#, you probably wouldn't need a border because anyway, you got an object. You have to run all the information about the array, right? Including the size of the array or the length of the array. So you just get a function call or method call to get the size of the array or the length of the array. But this is not the case for C++. That's why we have a second parameter, this array size. So we pass 10 for this instance, and we give for the given key, for example, maybe the key is 30, then we search for 30 in the array. And then we output, and they say if the search was successful, then we put, the array's location, the index is blah, blah, blah. Otherwise, we say the key or the element, the key that you provide is not in the array or something like that. Okay, most important, at the end of the program, because this dynamic memory, so we use a dynamic array here. This dynamic array was created at this point of time. So at the end of the program, we need to delete. It's a deleted array. All right? And you don't have to do this, but this is a good practice. And you should assign 0 or null to the pointer, which is safer. So if the pointer value is 0 or is equals to null, this means the pointer currently is not pointed to a location which is meaningful. All right, so this is just safer. Now, finally, quite quickly look at the 2 functions that we use in the main program. So this is to fill array. It's pretty simple. We use a for loop. From the first one to last one, we just use a cin to get the 10 if the size is 10, to get 10 integers 1 by 1 and put in the corresponding element of the array, right? And this search is also pretty simple. It's a linear search. So from the first element to last element, for example, let's say we have 2 elements, and the key we're looking for is 30. Then we start from the first element to say, if the first element is 30, no, move to the next one. There's a second round of the for loop. If the second element is 30, no, we'll move to the third, and so on and so forth. So there are 2 options. Either one is match up. Maybe we move next one. Next one is 30 and match up. Then we'll return the index, which is 3. All right? We'll assume it starts from 0, 1, 2, 3. If we have searched through all the elements but didn't find the key, then we return -1. So this should be an easy part. Now we talk mainly about dynamic array. We talk about dynamic memory management, and we use a dynamic array as an example. So the function is not the concentration of this lecture. What I'm talking about is dynamic array management. All right. So the idea is pretty simple, but in practice, sometimes you probably forgot to manage some dynamic memories that you use in a program. So just pay a little more attention to that. All right. Any questions before we move? Yes.
Is dynamically allocated memory automatically unallocated at the end of the program?
So you say again, automatically allocated.
Be allocated at the end of the program.
What did you mean by end of the program?
When you're done.
You mean allocation or deallocation?
Yeah. Does it deallocate automatically from the
You don't have to. This is just good practice. You don't have to do at the end, the bottom of the function or the program. So as you can, if you say, I use a dynamic memory somewhere, so when it's no longer used in the rest of the program, you can delete it. So you don't have to hold until the last minute. But it's good practice to handle all the dynamic memory at the bottom in one place. Right? It's just a matter of practice, good practice or bad practice. Nothing wrong, nothing right or wrong where you should delete it. Right? Any other questions? Okay. Oh. Or maybe we can take a 10 minutes break first. When we come back, we still got, we probably got 56, 57 slides. Hopefully I can go through today. We'll take a 10 minutes break first. Okay. What I'm going to talk about next is basically one is about C++ class, another, of course, is about C++ class and ADTs. And there are some difference between C++. When you create a C++ class and you want to use that class, which means you want to instantiate or create an object of class, there are two ways. One is called static way, another called dynamic way. So this is something where C++ is different from the classes in Java and C#. So just pay a little bit more attention to that, or come to that point. Okay, and also, as I mentioned earlier, I will spend a little bit of time very quickly talking about class string. That's the second type of string in C++. And finally, I talk about file input and output in C++. And of course, the most important part is the first one. This is C++ class. I'll probably very quickly go through this concept. I believe your guys are familiar with what you mean by class, right? The basic idea is in C++, we have a number of built-in types, like int or fundamental data types. Right? They are come with the compiler, so you don't need to do anything to use it, so you can directly use it. Right? But sometimes when you develop a system, there are some concepts in the real world which does not match to any of the built-in data types. Right? So which means you need to use a new concept to model that you use a new data type in your C++ program to model the concept in the real world, right? So if it is the case, which means you need to design or define new data types, right? So this is the idea. So basically, a class is a user-defined data type, all right? This is something that I want to emphasize because it's different from classes in Java and C#. In Java and C#, when you create or when you define a class, you put everything in a single file, which is java.java or .C# file, right? So whatever. But in C++, you put the interface of the class or the function prototype together with the class members in one file, which is .h file or headers file, right? I will give you an example very shortly. And you put the implementations, how each of the function implemented in a separate, in another file, which is a CPP file, all right? So this is the basic idea behind abstract data type. For abstract type, the basic idea is we separate the interface, we separate the specification from the implementation. Because by doing that, we can get a lot of advantage, a lot of benefits. So actually, I use this example previously, and I still want to use it. This example demonstrates the idea. So for example, int, right, which is a data type comes with a C++ compiler, right? When you use int, did you look at the int implementations for the operations like addition, multiplication? Did you look at that? You did not, right? All you needed to know is about the data type. This data type. Oh, C++ provides a data type int, right? We know what the values are for int, the range of the value, and also we know the operations defined on the value. So you don't need to know the details of the implementation to be able to use int, right? Similarly, when you define a new data type, a new class, you put the interface of the class in one file, which is .h file, and then you put the implementation in another file, which is CPP file. So the people who use your new ADT on the class only needed to look at your .h file. They don't need to worry about your CPP file, which basically included the details of implementation, right? They only need that, okay, what sort of data type it is, what sort of operation provided by this data type, and how to use it. I mean, the prototypes. For example, when I make a call to a function, what sort of parameters should I pass into the function, and what's the return type, and so on and so forth. So you don't need to worry about the internal implementation details. So this is the basic idea behind abstract data type. Okay, so from now on, when you define a new class, you should put the interface, basically cover the function members and the function prototypes in .h file. You put the implementations in separate file in .cpp file. Okay, I'll give you an example. This is an example. So for employee, so for example, you develop an application where you need to handle employee objects. Of course, you need to create a template. You probably use a number of objects of employee. So that's why you need to create an employee class. So in C++, if you look at the top, so this is the it's a header file or .h file. So this is the .h file. If you look at the .h file, you can see, you cannot see any implementation details. So all you can see, basically, number one, the bottom, the class members, right? So for example, for employee, every employee has a first name, last name, and also have an employment number, right? So three class members, right, which you put in the private section. Of course, you also need to specify the protection type level. So basically, this is the same with Java and C#. Three levels of protections. We have private, we have public, we have protected. But not here, we didn't use any protected. Anyway, so I don't want to waste too much time talking about that, assuming that you already know the protections. So this is the one set of component. Another one, so this is the one, this function prototypes. So those, if you look at this, you will know which sort of function, which sort of operation provided by this class. So for example, the first one, as you know, is a constructor. So which is basically used for, we'll talk about in more detail in a few minutes time, okay? So I don't want to waste time. And then there is a function called display. Display is to display the detail of the employee, for example, first name, last name, and employment number, right? So if you want to display, if you want to make a use of display, so you can say display, when you make a call to the function display, you don't need to pass any argument into the display. And display does not return anything. That's why it's a return value is a void, right? So you know how to use it, right? You don't need to look at the detail of display function implementation to be able to use it. So this is the core, this is the basic idea. Okay, there are a couple of places where we use const reserve word. So I just give your guys a quick explanation. So here, for example, if I use a const, anybody can tell me what's meant by this? For example, if I put a const or remove const from there, what's the difference would it be? Anybody can tell me? So if we put const over there, then in this function, so constructor is also special function, right? It's a function. It's a special function. You cannot make a change to first. For example, if you're in the constructor, if you are trying to do this, that's in the constructor implementation. For example, if you're trying to do this, in the specification, you said it's a const, which means you cannot change its value. If in the implementation, if you're trying to change the value, then this program would not compile. Okay, this what the first const means. It's similar with the other const here, so which means neither of them cannot be changed in the implementation of the function. There's another type of use of const. So this const is not used to modify those parameters, but put at the end of the function. What I mean by this is, if we put a const at the end of the function, that indicates this function, that function, cannot make a change any of the class members. For example, in this function, display function, you cannot do this. Underscore for example, you cannot do that. Can you tell the difference? The first one is this parameter is a constant. You cannot change the parameter. This one is for this one, this function cannot change any of the class members. So this is a class member underscore first class member. This is the parameter name. This is a class member name. All right. So if you're trying to do this in display function, your program would not compile. Okay. This is about const. So this is a good practice. So most of people don't use const, but const is a good practice. So if you put a const, so you can avoid a lot of mistakes, right? So for example, here, display only display information. You don't need to change any information. If you by mistake you're trying to change some information, then the compiler can pick up the mistake for you. All right. So that's a good practice. Now I'm talking about the implementation class, right? So that one, the one that I show you in the previous slide is the declaration or maybe interface of the class, depending on which terminology we use the terminology interchangeably. Actually, this is the implementation. The implementation I can see in the top is put in a separate file. Is in the .cpp file. That's the implementation file. Okay, just take another look of the declaration or interface. So in this interface, we have two function prototypes. One is basically a constructor, which of course is also a function. There's another function display. So how those two functions are implemented. So of course, if you have only .h file without the implementation, of course nobody can use it. You only specify, oh, this is a data type. If it cannot be implemented, nobody can use it. So this ADT must be implemented, or this function must be, class must be implemented before it can be used. Of course, it's common sense, right? So that's why we have implementation here. So basically, implementation we have two functions. The first one is constructor. The second one is display. We'll look at display first because it's easier. For the display, okay, this is a C++ syntax. You need to put this is the name, this is the function prototype, this is a function name, parameter, return type, const. This must be exactly the same with the one showing in the .h file. We also put a employee, which is the class name, followed by this operator. This operator is called scope resolution operator. So this the meaning is this function, this display function is the display function that is defined in employee class. There could be another display function which defined in another class, right? But this implementation is to implement the display function defined in employee class, right? This is what we call scope resolution operator. So this is the syntax. You have to do this, otherwise it would not compile. And then for this one, it's pretty simple. All we need to do is just simply output the name, followed by the first name, last name, and then we change our line, and then we output the employment number. So those are the member function, the class members, underscore. This is the convention that I use in class definition, right? So all the identifiers starting with underscore and is a class member. So for example, this is a class member, this is another class member, this is a third class member of employee. This is just a convention. You don't have to do that, right? Different people use a different convention. How to say which one is better than other, right? Okay, this one is easy, right? Except they're pretty much the same with Java and C# class, except for this, right? So this is the only difference here. Oh, one more thing. In the one common mistake in the specification or interface is there is a semicolon at the bottom. So in the beginning, when you start using C++ class specific .h file, so some people forgot put a semicolon over there. So if you didn't put a semicolon over there, the program you will get a complaint about the syntax or syntax wrong with your class specification or class interface. Right? Another function. This is also implementation. Okay, this is very important. This probably is new to most of you. So when we, as you know, for the constructor, this is a constructor, right? This is a constructor. If you look at, so this constructor, I should have mentioned that in this class, we use another class, which is string class, which I'll talk about right after this. Okay, so because it doesn't matter, it's very simple. So I would like to talk about this one first, and then look at the string class in more detail, right? So that's why. So we use a class. If we use a string class, so this is the second type of C++ string, which is a string object, right? So this is a string class. That's why we need to include string class, right? Which the string class is also in the std namespace, right? So that's a user string. Okay, if you look at this one, basically, when you create an object of employee, the object employee contains 3 class members. The first class member is first name. First name is an object of string, right? It's an object. It's not a reference. It's not a pointer to the string, but it's an object of string, all right? And the last name is also a second object of a string. And the third one is employee number, which is here is an integer, right? See, an object of employee contains 3 objects. We have first name, which is a string, last name also a string, and the third one is employment number, which is an integer, right? So if this is the case, if the object contains the other objects, then in C++, you have to use this constructor. This we call colon section. Why is it called a colon section? So if you look at it very closely, you look at the function prototype. So this first part, so this is a resolution, this is a class name, scope resolution operator, followed by the this is the constructor, right? This is the function name. This is the, those are the parameters, and then starting from here, starting with a colon. So this we call colon section. What do you mean by this? This indicate this is similar to this, just in the first one. This is equivalent. The first one, underscore first name this is equivalent to this, or sign. So this is a parameter, this is an argument. We assign argument to this side is the class member. We make a copy. Actually, we make a copy of the string because both of them are string type. We are assign this string to that string. We make a copy of this string and assign to that string. Okay, this is equivalent to that. In C++, if your object, if the object contains any other objects, not the pointer to the object, but the object, like this, then you have to use a calling session like this. You are assigned. The meaning is we create. So the meaning is we create an object of string for first name first, and this one, and then we create an object of a string for last name, and then we create an object of int for integer before we can create an object of employee. You have to do this. So why is it before? Because it's put before the opening bracket. Right? So you can say, logically you can say, this is the point. Opening bracket is the point where we create an object employee. So those three objects are created before we create an object employee. Okay? So you have to do that. Otherwise, your program will not compile. Yeah. So I believe when you do the assignment, you probably initially got some problem. Eventually, I believe we can solve the problem. Right? So this is probably one of the common problems when you're doing this first assignment. Okay, this is called the concept, which I'll talk about a little bit more. Okay, now another difference. I said earlier, you need to pay a little more attention to the class creation in C++. In C++, there are two ways of creating an object. One is called static creation. Another one, of course, dynamic creation. All right. Static creation is to create an object during the combination time. Dynamic creation is like a dynamic memory, so it's created during the runtime. And of course, the syntax are different. Okay. So this probably is new to most of you. Okay, now we look at the static creation of an object in C++. This is static. This is syntax. So once we have declared and implement our employee class, then we can use it now, right? So for example, if we want to create an employee class, let's say E1. E1 is an object. It's not a reference. This is different from C# and Java. This is actually an object. Okay. E1 is an object of employee class, right? So when we make a call, it takes 3 parameters: first name, last name, and employment number, which is 100. Then you create an object similar to this. So this is an object of a string. This is another object of string. This is an object of int, and then you create an object of this. So this is syntax. This is static object creation. Now we have a second one. Now look at the dynamic creation. So dynamic creation is the second way to create an object. So this is similar to the way you create an object in Java and C#. So you use new dynamic creation, always use new operator, right? So this is an example. This is basically the syntax, which we'll probably directly look at the example. So for example, if you want to create an object of employee using dynamic creation, object creation, you declare our employee pointer. So E2 underscore PTR is a pointer pointed to employee object. It's a pointer type, right? So this is dynamic creation. You can new followed by the data type. They're similar to new int, new followed by a data type. So employee is a new data type, so a new abstract data type, right? So you can use it. You can new followed by employee. So this is pretty much the same. So you have a first name, last name, and the employment number, right? And then you can, or you put them together. You combine the declaration with the initialization. So this either way is okay. So they are equivalent. So this is dynamic creation. Of course, for the dynamic creation, if the object is created statically, you don't need to worry about the memory management program because it's done by the system. If you use the second way, if you use the dynamic creation, of course, you need to manage. So if you don't use the object anymore in your program, you should delete it. Use delete operator because it's dynamic memory. Okay, this is just to give an illustration. So you have we'll declare, you have a pointer, this is a pointer. So this is done during the runtime, during the combination time, and this piece of memory, this object of employee, this is created during the runtime. So this pointer pointed to that one. Any questions about this? Okay. Delete, right? So the same. So you want to delete an object. Actually, when you delete an object, actually you return the space, the memory used by the object, back to the system, operating system, right? So you say delete, followed by the pointer. Has to be pointer, okay? You cannot use delete followed by object. Okay, you cannot do that because it will result a combination error. Okay, this is a very simple program demonstrating how to use static and dynamic creation of object in C++. This is a very simple one. So as you can see from there, so in order to use the ADT, the employment class that we just defined, then we need to include, right? So include. Okay, as you can see, there are two types of inclusions. If you use any class memories, standard class memories that come with the C++ compiler, so use this syntax, use the angle bracket. If you use a quotation mark like this, that's indicate this is a user-defined class. Okay. Whenever you use a user-defined class, no matter developed by yourself or by somebody else, so you have to use quotation mark rather than use angle bracket. All right. This is anyway very simple. Just pay more attention to that. It's different. So this is the static way to create an object. So this actually U1 is actually an object. And this is the second way to create objects. It's a dynamic creation. Of course, after at the end of the program, we need to delete. Delete followed by pointer. This is a pointer type. Pointer pointed to an object of employee. All right? So that's pretty simple. This actually output from that program, yes.
So to call a function using a pointer, you have to use the dash rate and then call the function instead of using the dot.
Oh, that's a good point. I was supposed to mention that. Yes, there are different syntax. There are different syntax, okay? You have eagle R. Actually, I was supposed to explain that. I forgot. So the syntax would be different. So we have two ways of creation, object creation. The first one is use object U1. So if U1, if you want to, for example, make a call, you call the class member function display to display the employee's details, first name, last name, and employment number. You use this one, dot. If you use a pointer, the second one, this is a pointer. If you use a pointer, you have to use this syntax. All right? Different. Yes?
Could you use the dereference operator to do star e2 pointer dot display?
Yes, you can do that. Yeah. So very good. That's a very good point. You can do the same. You can do, for example, you can replace this statement, this statement with this. E2 underscore PTR dereference. And then use a dot. Use a dot followed by display. You can also, so this is equivalent to that. You can also use a dereference. Good point. Okay, this is output from that program. Should be pretty straightforward, right? So I don't think we spend the time to worry about that. Now we look at the different type of class members in a C++ class. So typically we have constructors. Well, we could have more than one constructor in one class, right? So this is not new to your guys. And also we have destructors. This is new to your guys if you didn't have any background in C++. And we have accessors, we have mutators, which are probably not quite new to your guys. And also talking about other class member functions very quickly. Constructors, anybody can tell me what is a constructor very quickly? Yes?
Constructor is another function which is used to create concept.
Yes? This create an object. We can do something else. Yeah, of course, the major functionality is to create an object. This is what's a constructor about. We can also initialize the class member's value in constructor, right? That's a typically. And so how would you know that one is, for example, employee is the constructor? Because that function name has the same name with the class, right? So you know it's a constructor. So constructor does not have any, should not have any return type. So even you put a void, the compiler would not happy. So you cannot put anything for the return type because the constructor does not return anything. Okay, this is an example of constructor. The highlighted one is employees are constructor, right? That's just an example. This is actually, we have already talked about the calling section. So you needed to know when you have to use a calling section. But sometimes you don't have to, but it's a good practice to always use a calling section. This is a good practice. It's about practice. But sometimes you have to. If you don't use a calling section, the program will not compile. So when should you use a call? You have to use a calling section. When you don't have to, that's depending on the object. For example, if the object contains a number of references, does not have any objects at all, but contains a lot of reference, then you don't have to use a calling section. The program still compiles perfectly fine. But if an object contains any object, you have to create those sub-object first before you can create this object. So you have, if this is the case, you have to use a calling section. Okay, so just a repeat because it's very important. I believe some of you may got this sort of problem in the future. All right, so the syntax. Another one is default constructor. Anybody can tell me what is a default constructor? Basically, a default constructor is a constructor which does not take any parameter. Then it's a default constructor, right? So, for example, for one class, you could have multiple constructors like this. You have two constructors. The first one is a default constructor. For default constructor, because you don't pass any parameters into the constructor, then when we make a call to the default constructor employee, which is the first one, number one, you create an object. That's not all. Number two, what are you going to do with the three class members? You use their default value to initialize those three class members. So for example, string is an empty string. First name, empty string, last name, empty string, and employee number 0 because default value for integer is 0. Right? That's it. You create an object like that. Okay. So this is the basic implementation. Constructors. There's another question to challenge your guys. In C++, actually, it's already showing on the slides. In C++, when you define a new class, you don't have to. It depends. Sometimes you don't have to put a constructor, which is perfectly fine. If you look at, for example, the prototype, the class interface, you cannot find a constructor for some of the classes, which is fine, perfectly fine. If this is the case, if there's no constructor defined in the class interface, and you make a call to the default constructor, the system will create a default constructor for you automatically. Of course, when doing that, the initial, the class member value using their default values, right? But once you have already included or defined a constructor in your class, which probably is not a default constructor, and you want to make a call to default constructor, this will result or error from the system. This is not good. All right? So this is what I'm trying to say over there. Now, destructors. Destructor is used to basically to destroy the object. Constructor is to create an object. This destructor is to destroy the object. Is to return the space memory used by the object back to the operating system. All right? So this is destructor. And whenever, so we'll talk about the delete, right? If you use, for example, delete followed by a pointer to a class object, actually this will result a function call to the destructor define a class. And the destructor basically is a return space. This is how it works. Delete works, right? I repeat. If you start, for example, if I have a pointer, let's say PTR pointed to employment object, and then you have a delete PTR, this will result a call to the corresponding destructor in the employment class. So when you make a call to the destructor in the employee class, of course, they will delete the employment object and return the space back to the operating system. Okay? So how to, sometimes, most of the cases you don't have to worry about destructor. But sometimes you do need to define the destructor. For example, when your class uses some dynamic memories, so if you simply have like an employee which contains all the all static memory, there's no dynamic memory. For example, first name, last name are both static objects, right? So you don't need to worry about that. But if your class has a class member which basically is a pointer type, is pointed to another memory. In the destructor, you need to delete all the space before you delete itself. Do you understand that? Okay. This is a destructor. Very quickly, talking about accessors and mutators because they are not new to your guys at all. Accessors basically is a function which used to access the value of a class member, and the mutator is to change the value of our class member. That's what we call mutators and accessors. So for example, here we have two typical functions. One is set employment number, which means we need to change the value. Right? Change the value is a mutator. And get employment number, of course, is we only get the value, we don't change the value. Right? So this is why I put a constant at the back, because we only get the value, we don't change the value. So it's accessor, it's not a mutator. Right? So this is the accessors and mutators. So those are the implementations which are very easy to understand, right? So other functions. So typically, a class member function looks like that. You have a return type, you have class member name, class function name, followed by a list of parameters, right? The similar, or arguments, whatever you call, right? So this is that. The bottom one is an example. For example, we have a member function employment class. The return time is a void because that's not to return anything. The class name is class function name is called display. Does not take any parameters, so it's a void, right? So this, and because this display is something like accessor, it's not a mutator because it does not change the value of any class members. So we put a const at the end of the function prototype. So that's pretty easy. Yes.
So if a method doesn't have any parameters yet put void, we could just say display open.
Either is okay. If you don't put anything over there, or you put a void there, either is okay. Doesn't matter. Doesn't matter. Yeah. Okay, another concept is called member function overloading. So anybody can tell me, do you know what you mean by function overloading?
Using the same name for different functions, but using different class arguments between the functions. So if you want to call it nothing and then
Exactly, yeah. Exactly, thanks for that. Yeah, so in one class, you may have more than one functions which has the same name. They use the same name, but of course, has to be different parameter list. Right? Otherwise, the computer will be confused. Right? So, for example, here we have two displays. Right? Same name, exactly same name, but they have different parameter list. So the first display does not take any parameter, whereas the second display takes one parameter, which is employee type. Okay. So the implementation details are pretty simple. So just yes.
Just go back a slide.
Sure.
When you create the object with the constructor, you're defining this constant, and then your mutator set employee. How does that change that if it was set as a constant initially?
You say it again. You're talking about which function?
Set employee number changes the employment number.
Set employment. Okay. Yeah. Yeah. Right. The set employment number means we change the class members. There are 3 class members. One of them is employment number, right? So set is a change employment number, which encapsulated in the object, right? Where we put a const, that const is for the parameter. It's not for the class member. So which means you cannot change the employment, the parameter's value, but you can change the class member's value, no problem. The second one, the next one is set employment number. This is just the other. That's right. Class member cannot be changed. No class member can be changed. That's for get employment number, right? You got distinguish the parameters from class members. All right. One is apply the constraints applied on class members, and that is on the parameters, function parameters. Okay. Okay. Anyway, so this is pretty straightforward. I'll have to leave this one to you because you've got some other to talk about very quickly. String class. Okay. This is the second type of string. We mentioned that there's one type of string which is C style. When we say style, I mean our string is treated as an array of characters. So this is what we were talking about last week, but didn't have too much time. Anyway, it's pretty easy for you to understand. So this is the second one, because in standard class library we have a string class. It's a predefined class, right? Which means we can directly use it. So for example, if you can create an object very quickly, right? So there are a lot of operators. Actually, those are for those of you who understand operator overloading. Anybody heard of operator overloading? Nobody. So you didn't know operator overloading. Okay, I'll talk about next week. So anyway, those are the operations defined for string object. All right. So just understand. Actually, how this implement, they use operator overloading. So you don't need to worry about the implementation details. You just need to know. So what operations are provided for the type string? String is considered as a type, right? So for example, if you want to get a string, you can use a string insertion operation. So this you can get it from the keyboard. This output a string onto the keyboard. If you want to read a string from input, you can use a cin, and this will go to the string. That the input from keyboard will go to string object str. This is an object str1 is an object. These are static object creation, not dynamic. Of course, you can always do the dynamic create a string as well. So there are some others, for example, assignment. You can assign, there are different ones. Assign hello to a string object. You can do that. Why you can do that? Because the assignment operator has already been overloaded in string class by somebody else. You can directly use it, right? So you can assign one string to object to another string object because of the object. So this is different from array in C++, right? So this is an object. You can copy one object to another. That's perfectly fine. And of course, there are some other type of, you can assign, for example, even a char to our string and so on and so forth. Okay, you can also compare two strings, to see which one is bigger, which one is smaller. How? This is just alphabetical order. So you can use a dictionary order, something like that. And also you can use a cancellation operation. So you put two strings together to form one. So of that, there are different ways. I have leave this one to your guys. Yes?
So the comparison wasn't like the bits or?
Not the bits, that's the order. So for example, the alphabetical order. So for example, if I have a string A, B, C, this is one string. Then you have another string, the B, B, C, for example. So this is larger. So if you can do comparison, you compare two strings. So if, for example, if you compare this one, no, that one. You have to use a string. For example, st string 1 like this. Let's say st1 is equal to this, and st2 is equal to that. You can st1, st2. This would be return true, because this one is larger than that one. We use alphabetical order. Okay. Also, that operator, subscribe operator, which is also overloaded, which means given a string, you can look at a particular character in this string at a given location. For example, index 1, index 0. And this is an example, so I have to skip this example. This is pretty straightforward, pretty easy, right? So I leave this one to you. This example is output for the program. Anyway, I don't think in today, this week's practical, you need to use a file input and output. So maybe I'm running out of the time again. So I will talk about this in the beginning of next week's lecture. So I would suggest to quickly look at the rest of the slides. So next time I'll go through those slides very quickly. All right, thank you.